Hey guys, I want to explain something about pressure to you, air pressure, because it's all around us. We don't realize it because it seems so natural to us, but we can make it visible very easily. So this is a bottle and it stays in shape. It's not actually, I'm not making advertising here, but anyway, it stays in shape because it has a pretty firm material known as plastic, but when I put some force to it, I can obviously move it and change its shape, and it might actually stay like that. Okay, like it is here, I changed it and it stays like this. Okay, so far so good. We always know these things, but what about air pressure? Why is this thing even staying like this by itself? Well, first of all, because the material is strong enough to withstand, to resist the air pressure that is coming from all sides onto this object. At the same time, I have it open, there is air inside that bottle. Right here. The air is around that bottle and air is inside that bottle. So, if I close that, now is there nothing inside this bottle? People would say, well, it's empty because there is no water in it. But I say it's not. It's not empty. It's an illusion because there's air inside. That's the important thing. So when I press something, it goes right back. Okay? Because all I'm doing is just pushing the air that is inside around, but the air goes right back. Okay? So if I try really hard, it's coming back. You see? You heard it? It's even popping back because the air is just being pressed inside that bottle and then it has to go somewhere. Okay, so if I would press hard enough, I could actually rip that. Okay, when I open this back up, and I have to do everything with one hand, I'm sorry, because with the other hand I'm holding the camera, but what I'm doing now is the same thing that I did before, and it stays because the air can escape. I opened the bottle, so I have to put air back into it. I'm blowing air inside. You're not gonna see this, but you probably heard it, and it's right back. Okay, now there is a perfect equilibrium between the air that surrounds this bottle and the air inside the bottle. Okay, and I can try to get some more air into that bottle, but it will always come out of it again the moment this bottle is completely filled with air, and right now it is. So if I go, for example, and I suck out the air here and I create a near vacuum within that bottle, which I'm gonna do now, you cannot see, but just for the sake of showing you, that's what I just did. I sucked out the air and then I closed the bottle quickly. Nothing new, right? But the understanding behind this, that's what people, that is usually new to people, or they forgot about these things. Because what's going on is, there is only a certain amount of air inside this bottle now. Because the space has decreased. The bottle has gotten smaller, so there is not as much air inside that bottle now as it was before. And at the same time, the air around this bottle is also creating pressure onto the bottle. Okay, that's air pressure. And because there cannot exist something like a vacuum nowhere in nature, and I vacuum out the air out of this bottle, it squeezes together. And the material of the bottle is not strong enough to resist that pressure and that force. Because there's a force that is going outward from vacuuming, you know, sucking out the air out here. There's a force into this direction, and then there is force that comes from the surrounding air that is squeezing the bottle, because there cannot exist a vacuum. And what a vacuum means is no material at all. That's why I said this bottle is not empty. We can try to make it almost empty, but still it's not empty. And even if I would try harder and really try to pump out all the air, it will not work. There are mechanical pumps, almost like vacuum cleaners, that are not strong enough to pull out all the materials inside an object, simply because that's not possible in nature. And the pumps are not strong enough. You cannot build something that is stronger than nature itself. It's a nice realization, right? So far so good. Now, why would all of this be important? Because, as I said, this is not something new to most of you, but it's a remembrance of how things in nature truly are. This bottle is not empty, there's air inside, only you cannot see that air, it's a gas. You will call it empty just because there's no water inside, but it's a different material that is more visible to the eyes than air. It's a liquid. Air is a gas, and the container of the bottle is a solid. And why is this important? Because there are people in this world that are trying to fool you with going to the moon with a rocket. And maybe you heard about the story that aired a few months ago, where they were trying to look for the Titanic, and the whole story was about a submarine imploding underwater because it could not withstand the pressure of the water, the surrounding water. And if you consider this now, the submarine, and the air that surrounds this bottle is actually water, then it would do the same thing. Okay, it's imploding because the pressure of the outside material is stronger than whatever is inside, and it's imploding. Of course, in this case I sucked out the air artificially to create this, but with a submarine underwater, the submarine just implodes because the walls are not strong enough to resist the huge pressure underwater at a certain depth. You cannot go to the bottom of the ocean at some cases because the bottom of the ocean is too low for people to reach. And this happens at certain depths. And the same with altitudes, only that it's inverted. That means when you have a container that is filled with air and you take it up into altitude, at some point, at certain altitudes that are above 400 kilometers, the object and its walls cannot resist the pressure that is coming from inside working outwards, because there is very low pressure surrounding this object. So at some point this thing will burst into pieces. If we think, for example, this is the rocket going up into space. In space there is a near vacuum, that means there are gases that are lighter than air and they are very far apart in material. So there is a sort of near vacuum, but not a complete vacuum, a near vacuum. There is still material, there are still gases. Just very, very thin gases that are even thinner than air. So when you have air inside a container, a metal construction, which a rocket is, and you take it up into altitude, into a near vacuum, then at some point the walls of this container will not resist this pressure from the air, because the pressure outside and the pressure inside are so much different that it creates a imbalance, and we know that nature is all about balancing itself, creating this equilibrium that makes life possible, and that's why it's gonna burst. So if you think that anybody goes to the moon, it's not possible, it's a lie. And we just have talked about metal constructions filled with air. We haven't even yet talked about bodies, human bodies that would suffer lethal consequences before they even reach the moon. So it's not about the distance that you cannot go to the moon. It's actually about physics.